Okay, so I actually have not been doing nothing. I have been going to a community biology laboratory called BioCurious in the Bay Area. And this place is awesome, man. I think there was an initiation fee of like $100, and then the monthly fee of like 120. I think I spent 250 overall, and in the coming months it'll only be like 120 per month or something. But that's not the important part. The important part is they have a ton of equipment. I can even, well, I don't want to show it. I just want to recap what I did. So this is going from like zero to something, 0 to 1 in biology, basically. Because what I have, wait, hold on. Okay. So I have some chemistry experience. Wait, I think I did it the wrong way. Let's see. Hello? Okay. And so it was very intimidating. I got in and I was like, whoa. Like there's like shelves of chemicals, there's like a million freezers and fridges, and then there's, all sorts of equipment that I've never used before. And I was like, well, I've done one protocol and I did it, pretty jank here at home with pouring LB auger plates. And I didn't have any ampicillin, right? So I just poured those plates. Speaking of, I really need to go autoclave those in the Instant Pot because they're probably gross. And I haven't looked at them in a couple days now that I have a real lab that I can go do stuff at. Um, I'm actually planning on, I have my GoPros and I'm planning on strapping a GoPro to my chest and just recording the stuff that I do. I think that'll be pretty exciting. It's sort of a middle ground of like, of course, I don't own the space, so I can't just go in and do whatever I want. But anyways, the um the first day, so yeah, I was just really overwhelmed. I was like, I don't really know what to do. So I just decided, let me just do the exact same protocol that I did. It's the Adgene LB Auger plate pouring lab. And this actually turned out to be a really good decision in my opinion because I had to learn where the chemicals are stored and how to like search for a chemical. There's a ton of chemicals that are just community use. And so if no one's name's on it or it says community use, you basically have a free reign to use it. Obviously you want to be respectful and not just like waste and whatever. But then use their analytical balance and all that stuff. And then the other cool thing that it taught me is how to use the autoclave. So this time I actually sterilized my media in an autoclave, which is pretty cool. And so I did that. And then this time what was cool is I made a stock solution of a milliliter of 1000x ampicillin. And one thing that I really, and so that's great. And so we're going to actually find out today. So one thing that's really nice is there's this guy there that helps me out with a ton of stuff, just like answering my questions and everything. And he streaked out a petri dish of two different strains. One strain is something that has pea glow in it. So that's the glowing plasmid that, in the presence of arabinose, will produce the green fluorescent protein. And then on the other side is NEB stable, which is like a very common cell line. And it was great that he did that for me because then I didn't have to spend like $90 getting the plasmid from Adgene. And it actually added a cool complication to what I have to do because um I need to actually purify or do basically what's called plasmid extraction. I need to get a plate or a liquid media that yeah, I think I need a liquid media of the competent, I think it's called competent cells or whatever, but it's something that has the arabinose, the ampicillin, and then the media in liquid form. And I want to actually today, so I have kind of two experiments that I ran. One is I took the plates that I poured from the first day that have ampicillin, and I streaked out two plates, one with NEB stable and the other with P glow. And what we are hoping to find is that the NEB does not grow because the ampicillin kills it. then the pea glow does grow because it has ampicillin resistance. So that's just to check if I made the plates properly, basically, because I put them in at like 62C. So we would just want to check that it didn't denature or anything, or I didn't put too little in, because maybe I did my math wrong. So that's the first experiment. And the second experiment is going to be, I made some liquid media just at the very end, um, that has, ampicillin, arabinose, and by the way, when I made my arabinose stock solution, I really kind of fucked it up because it didn't. I made it 2 grams per 10 milliliters. I made 10 milliliters with 2 grams of arabinose, L-arabinose in it. And the question is, well, anyways, like some of it didn't dissolve, and when I poured it off into my test tube to store, a lot of anyways, I spilled, so it's not very accurate and whatever, but we'll see if they grow, and we're going to check under a UV light, and that's what I'm kind of hoping to get on my GoPro is some shots of that. One thing that I'll have to do is, speaking of, I bought some spray bottles, and I bought some 70% ethanol, and I'm going to bring that to the lab, I think, so I can use something to disinfect. They have a bottle of hydrogen peroxide, but I don't know. Everything I've seen says use 70% ethanol. Anyway, so we're going to then take that liquid media and do plasmid extraction. So we're going to take whatever's growing in that liquid media and then follow this protocol where someone gave me a kit. So they have these kits for free. They're called BioEngineering Mini Prep Plasmid Extraction Kit. Anyway, so it has all the buffers and all of the materials that you need to extract the plasmid at pretty high fidelity, or I forget what they say, purity or whatever, integrity. Anyways, and that's actually something that's really cool because I plan to do this experiment a few times, I think, because there are a couple of things that you can do to verify that you extracted it properly, which for me, I'm actually really loving that bio seems to have, it feels like real science, which is nice. You really have to confirm that what you're doing is the right thing. Whereas I feel like, well, I guess I haven't done really chemistry. I haven't really done a lot of true science, but I guess what I was thinking of is like, when I was building the CNC machine, there was not a lot of experimentation or like science, really. I mean, I did basically one experiment with the load cell to check for flatness, but this is like much more science, which is cool. And anyway, so you do 2 things. One, you put your extracted plasmid in a spectrophotometer, and apparently there's just a known value that the ratio of the absorbance of the liquid at, I think it's 260 nanometers divided by the absorbance at 280 nanometers or something like that tells you, I guess, if there's DNA in it. So that's pretty cool. Then the other thing you can do is you can run it on an agarose gel and do gel electrophoresis. And that is something that I very much want to do. And I think they actually have like a little box where I could record the results of the gel electrophoresis. Then, so today we'll basically just be doing plasmid extraction. And then after the plasmid is extracted, I can actually do the normal P-glow lab, which is actually doing the heat shock and the what do they call it? There's a name for when you heat shock and then you freeze it so that it takes in the plasmid. And then we can check if basically I did a bacterial transformation properly. So that's sort of the next thing. So that's pretty sweet. That's the plan, is to do plasmid extraction, to characterize the quality of my extraction, and then to use the plasmid extraction to do the standard P-glow experiment. Once that's done, I will find another project, and that's probably going to be the repressilator. And there, what's cool is I'll get to do a live stream where I design a plasmid. And speaking of, I need to reach out to the Cello CAD people. So that's that. Anyways, this is just a short video on like me going from 0 to 1 in synthetic biology. Okay, that's it. I'm gonna change the title to this, I think.